All right, let's dive right in. We're going to explore this incredible puzzle that's happening right now, deep inside the living world. I'm talking about everything from swarms of bacteria to the very cells that make up you and me. And at the heart of it is this mysterious little dance that seems to defy the laws of physics. And trust me, figuring it out, well, it changes pretty much everything we thought we knew about how life works.
So, what are we looking at here? Scientists call it active living matter. And you can just picture it, right? A super dense swarm of bacteria, or maybe a layer of your own tissue cells growing. The one thing they all have in common, they are never ever still. It's this constant state of, well, it's beautiful, chaotic motion.
Okay, so right at the center of all this chaos, you find these fascinating little things. They're organized imperfections called topological defects. And really, all that means is they're these specific points where the usual, neat alignment of cells just breaks down. It creates this tiny, predictable disruption in the pattern.
But here's the thing. These are not just random glitches. No way. They are absolutely fundamental to how these living systems move and organize themselves. And it turns out there are two main types, two opposing characters in our little drama.
Yeah, the technical names are, plus 1/2 and minus 1/2 defects. A bit dry, right? But just look at them. It's so much easier to think of them as tiny comets and tripods zipping around in this ocean of cells. That's exactly what they look like.
So these comets and tripods, they have this really dynamic life cycle. They're always born in pairs. You get one comet and one tripod. And eventually, they find an opposite partner, collide, and poof, they're gone. But it's the bit in between, when they're interacting. That's where things get really, really weird.
And this, right here, is the core of the whole puzzle. You'd think, based on physics, that they just move in straight lines, right? Either pulling towards each other or pushing away. But they don't. They dance. They actually spiral into each other before they disappear and spiral away from each other when they're created. And that spiral, that's our big mystery.
All right, so to understand why this is such a puzzle, we need to look at the standard theory. For decades, the go-to explanation for all of this was a framework called the active nematic model.
So what does nematic even mean?
The key idea here is alignment, but with no specific direction. The best way to picture it is to imagine dumping a box of uncooked spaghetti on your kitchen table. The noodles all kind of line up, right? They have a general alignment, but there's no front end or back end. They're all just rods.
And here's where it gets really interesting. When you run the numbers, when you actually do the math for this nematic model, it makes a crystal clear prediction. It says the forces between our comets and tripods should make them move in perfectly straight lines. Period.
And that's a huge problem, because our best theory says straight line, but what we actually see under the microscope is a spiral. So the model, as useful as it's been, is clearly missing something. There's a piece of the puzzle that just isn't there. So what is it?
Well, the answer, it turns out, comes from a totally different kind of order. A different type of symmetry that was basically hiding in plain sight this whole time. And this is called polar symmetry. Now, in a polar world, direction is everything. It's not just about lining up. Think about a school of fish, or maybe a marching band. They're not just aligned. They are all pointing and moving in the exact same direction. They have a shared front and back, a head and a tail.
And that really just nails the difference, doesn't it? Nematic is like the spaghetti, alignment but no direction. Polar is like the school of fish, alignment with a clear, built-in arrow showing which way to go.
So what on earth does this have to do with our bacteria and cells? Well, think about it. They move, right? They propel themselves forward with tiny little motors. And that ability to move, to push forward, is inherently a polar property. Each individual cell has its own little engine and a direction it's trying to go.
Okay, and this is it. This is where we crack the case. The mystery of the spiral isn't explained by the nematic model, and it's not explained by a purely polar model either. The secret is what happens when these two worlds collide.
There's a research team that put it perfectly. They said that real living systems have a mixed symmetry. You've got the nematic alignment from the shape of the cells, but that exists right alongside the polar symmetry of how they move.
And this is the big aha moment. Here's how it all comes together. The nematic alignment, the spaghetti-like part, sets the stage. It creates our comet and tripod defects in the first place. But then, that hidden polar force, the fact that every cell is trying to move somewhere, adds a sideways push on those defects. And that sideways push creates a twist, a torque. And what does that torque do? It turns a straight line into that beautiful spiral.
It's a perfect explanation. The spiral wasn't some mistake in what we were seeing. It was the physical signature, the clue that there was a hidden polar force at play in this pneumatic world. That little dance was telling us all along that our rulebook was missing a page.
Okay, so let's zoom out for a second, because this is way bigger than just solving a cool little mystery about a spiral pattern.
This discovery really forces a huge rethink. It shows us that our old models, they were just too simple. Living matter isn't purely pneumatic, and it isn't purely polar. It's a hybrid. It's a fundamental blend of both. And that's not just a tiny tweak to the theory. It's like opening up a whole new chapter in how we understand this stuff.
And getting a handle on this dual nature is absolutely crucial. Why? Because this new way of looking at things gives us a much more accurate tool to model really complex things, like how our tissues develop or how a cut heals. It could even unlock new ways to design living materials, materials that can literally build and repair themselves, just by using these same basic rules.
So in the end, by solving the mystery of this one tiny spiraling dance, we've actually uncovered a much deeper rule about how life itself gets organized. It just goes to show you, sometimes the biggest secrets are hiding right there in plain sight. Which leaves you wondering, right? What other hidden rules, what other secret symmetries are out there shaping the incredible living world all around us?